morning, everyone. Okay, today we are going to finish our chapter 15 on page 291, problem solving. This is just the objective. Okay, before we move to our lesson, just revise back about what we have learned. Just determine the value of x if I have this equation. 25 to the power of 2x equal to 625. Okay, as the answer, here we have the equation as the index notation, so we need to solve it by index form. So we change 25 into 5 square, so we get 5 to the power of 4, yeah, 4x. And this is 625 equal to 25 times 25, so we can write down as 5 to the power of 4. So the same base we can solve for the power, so we get 4x equal 4, and we want to get x it will be 4 over 4 equal 1, yeah, therefore x equal 1 as the answer. So just warm up. So this is a simultaneous equation related to the power or index notation. Here the equation given, yeah, and the simultaneous equation given just 125 to the power of x plus y equal 25, and 3 second equation, yeah, 3 to the power of x minus y equal 81. So to solve this one, we need to change each equation here as in the notation in the small base or simplest base of it. So this is 5 to the power of 3, yeah? We can change 125 here to 5 to the power of 3, and then to the power of x plus y. 25 change to 5 square. This is the same thing, we can change to 3 to the power of 4. So the same base of each equation, we can omit the base. So we get 3x plus 3y equal 2, the first equation, and x minus y equal 4 is the second equation. So we start solving this one. We just take the second equation times 3, so we get a new equation. I name it to be the third equation here. So I just take the first equation plus with the third, I will get 6x equal 14. Just solve for x, so I will get x as 7 over 3. We need to substitute the value of x equal to 7 over 3 into 2 in order to find out y. So I substitute into 2, I'll get 7 over 3 minus x equal 4. It's implied y will be equal to minus 5 over 3. So the solution set is 7 over 3 as x minus 5 over 3 as y. Okay, move to our lesson today, just about problem solving on page 291 in our textbook. We need to solve the simultaneous equation in this form. So in the warm-up portion, I just showed you about index form, but this is in fractional equation, and the y, the denominator, just in the variable xy here. So in order to solve this type of equation, we need to reduce it into the simultaneous equation into variable. So we can change it like this. We can let a to be 1 over x and b 1 over y. So we can change the equation of the first one here, 4 over x plus 15 over y, by using ab. So I will get this, yeah, 4a plus 15b equal 15. I name it to be the first equation, and the second also I can change to like 7 over 5a minus 6b equal 3, the second equation. We need to solve these two equations, the first one and second one, simultaneously. Okay, so I take this second equation multiplied by 5 over 2. I intend to omit y, omit b. So I get a new equation as here. I name it to be 3, so I take 3 plus 1, so I will omit b. So I have 15 over 2a equal here, 22 1 over 2, and then solve for a. I will get a as 3. So I substitute a equal 3 into the second equation. I will get this one in order to find b. I get 6b equal, yeah, I multiply this and then subtract, so we get 1 over 5 as a mixed number, and then get b as 1 over 5. Okay, so after I get AB it is not the answer what we want to find. What we want to get just the value of x and y. So we need to substitute what we let in the beginning. A equal 1 over x. So it's equivalent to 3. Yeah? 3 is A here. So 3 is A just equal to 1 over x. When we solve for x, we get 1 over 3 as the value of x. And for B, the same thing. We need to substitute the value of b by using 1 over 5. So equal to 1 over y here. It's implied y equal to 5. So right now we get a value of x as 1 over 3 and y equal 5 as the solution set. Okay, move to the second example. For which value of p does the pair of equation given below has a unique solution? Okay, here the equation, yeah, the simultaneous linear equation into variable like y. So what is the value of p? Yeah? What are the value of p? Yeah, make it has a unique solution. You know unique? Yeah, unique it's mean only one, right? So it's mean that these two lines are intersecting at a point only, yeah, which we have a unique solution. So depending on what we have learned in grade 8, you should remember about graphing as method in solving simultaneous equation. So there are 3 main possible cases. So before we start solving this problem, we should revise back about the solution, special case of the solution in simultaneous equation. Okay, if we have this simultaneous equation, you compare to the top, it's look like it. See? So I name this general simultaneous equation as a1x plus b1y equals c1, a2x plus b2y equals c2. Then we get 3 possible cases of the special answer or solution of it. The first one, if we get the ratio of coefficient of x not equal to the ratio of the coefficient of y, we get a unique solution. It means that this simultaneous equation has only one solution. And then the second case, just when the ratio of the coefficient of x equal to the ratios of coefficient of y and equal to the ratio of the constant value here. So we can say that there are infinitely many solutions. Yeah, it's mean the two lines are coincident, just overlap. And the third one, when a1 over a2 equal to b1 over b2, it is not equal to c1 over c2. So this is, there is no solution. It means that the two lines are parallel. Yeah, the two lines are parallel. So this is just the 3 special cases of solution in simultaneous equation, which you have to remember. So now move back to our problems. What we have here, just the equation which we need to determine the value of p when we have the simultaneous equation. 4x plus py equal minus 8, and the second equation 2x plus 2y equal minus 2. So like what we know, 4 here represent a1, right? P here represent b1, and minus 8 here represent c1. And then this one represent a2, b2, c2. So for the given pair here, to have a unique solution, we need to compare the ratio of the coefficient of x, yeah, a1 over a2, and the ratios of the coefficient of y, yes, b1 over b2. If they are not equal, so the given simultaneous equation has a unique solution. It's just identify now. A1 represent 4 here, A2 represent 2 here, B1 represent by P, B2 represent by 2. So we can substitute into this expression. We get 4 over 2 not equal to P over 2. It's mean that P not equal to 2, 4. P is not equal to 4. There are too many value, right? There are too many values. So therefore, for all values of P, yeah, all value of P's, but we except 4. It means we don't take 4, right? Beside 4, P are available. The given pair of equation will have a unique solution. Okay, so it is time for you to do a classwork. And remember the 3 special cases. Now I just give you one example related to the first case. So the other 2 cases, try to work on it by yourself. And also need to remember, if you have the exercise related to that question, you have to remember the special case. So for classwork, so the following simultaneous equations. We have 4 exercises. The first one here, a 5 over x minus 6 over y equal 1 and 17 over x plus 30 over y equals 16 related to my presentation, and B related to the warm-up question. And this one also you can use a substitution method, yeah. And this is also, yeah, use your understanding related to the reducible method for helping us to solve the simultaneous linear equation. Yeah, thank you for your paying attention. Goodbye.